Alright, hey everybody, welcome to the introduction for episode 4. So, this episode today is going to be split into two parts, which is going to consist of the two videos, so I can just try to follow my double upload schedule. But in the first part of the video, I'm going to show you how to actually plant the seeds. So, this showcase right here is going to showcase both of the parts. But I'm going to first showcase the planting the seeds part. Which, okay, if you go over here and you bought some seeds, like so. And you also notice that I added a couple seeds, which I'm going to show you how to do in the video later. And all the seed models and stuff are going to be in the description. And in the Discord as well if you'll join it. So if we go over here, you notice that when we equipped our tools, our plot is going to be highlighted, showing where we actually can plant it. Another thing I did is that you can't plant seeds too close together. So what I mean is that let's say you plant right here, you can't plant like right beside it like so. You have to wait a little, or you have to plant sort of next to it, not on top of it or anything like that. And so you notice that we have a cool looking growing animation. And we also had a compatibility for different seeds. For example, we have blueberries, which you can plant it. And here we have tomatoes. You see, they all have different animations. And finally, for the cacao seed, it's going to be a really big ass sort of tree, as you can see. So, as well as that, you can also customize how the growth time of each plant and things like that, which I'm going to show you how to create in the video. But for now, if you go over here to your modules and seed data, you see that each seed has sort of a configuration model. So you see that, okay, we have growth time, we have harvest count, so how many actual harvestable plants are going to be on each tree. Or if it's just a single harvest, which is multi-harvest at defaults, it'll just be a single plant. And once you harvest it, it's going to go away for good. And yeah, so once again, let me showcase you planting the seeds. So you have a tomato seed, and you notice that has a cool animation. And yeah, so once again, the first part of the video is just planting the seeds in general. So you press on the ground and you plant the seed and it has a cool little effect. And the second part of the video is going to be the actual growing system of the tutorial, where the plants can grow and have a custom animation for each of them, however you want. And yeah, that's pretty much it. I hope you enjoy the video, and please leave a like, comment, subscribe. I really put a lot of effort into this video in particular because I had to stay up last night just trying to figure out how to make it simple for y'all without making the video too long. So yeah, hope y'all enjoy the two parts of episode 4. Alright, hey everybody, welcome to part 1 of episode 4, which this part is going to go over how to actually plant the seeds into our plot. Whereas part 2 is going to go over the actual growing of the seeds and the client visuals for it. So the first thing we want to do is, I'll have linked in the description, or you can get in the Discord, an assets model that has all of the seeds and things like that. So if you get it, you'll see that, okay, we have a plant effect, which is this. So whenever you plant it, there will be a sort of effect in the ground, as well as some plants. So you have your blueberry, your tomato, and things like that. All of these I found off of the toolbox. They're free models, but I edited them a little bit to match how we want them to look in the game. So a sort of few precursor things I want to note is the way we're going to be planting the plants in the ground is going to be through or the visuals for them at least, are going to be through a client script or a local script. Because we don't want the server to like have too much strain on it. So we don't want the server to constantly be animating the plants as they're growing and things like that. We only want that server to hold data that is crucial for allowing the plant to grow. While on the client, we can actually animate the plants growing. So for example, on the server, we can just make a part that'll act as a mock part for where we want the actual client model to be. And then in that server model, we can add values like growth percentage, can harvest, things like that, or mutations as well in the future. So if you open the folder and let's, for example, go to our cacao plant right here, you see we have a client model and a server model. The server model only contains things that the server wants to see. Like we have a primary part for where we want the plant to be, and we have fruit prompts, which correlate to whenever we add in harvesting, which we can add a proximity prompt in each of these where we can harvest the plant. But if we go to our client model, you'll see that, okay, we also have a primary part, but we also have all of our tree and things like that. So we have our fruits and stuff, which if you open them, you'll see an attribute called FruitNumber. This allows the server to know which fruit the client model's fruit is. So for example, this is fruit number 1, this is fruit number 2, fruit 3, fruit 4. These names also have a special meaning, which I'll go over in part 2. And in our main model, you see something called AppearPercentage. So what this will do in our script is that we'll have a value called growth percentage. So whenever the growth percentage hits or surpasses this value, the plant will animate and grow that part of the plant, which allows us to make custom animations for it based on how much percentage of the plant is actually grown. So now that the explanations are out of the way, we can go ahead and just move this to replicate storage to assets and start working on our planting system. So the first thing we want to do is that we want to head over to our inventory service. And you'll see up here we have our create new tool function right here. But we also want to, so for every single seed we want to have planted, we don't want them to have separate scripts in each seed. So what I mean is that, let's say we have like, okay, we have a carrot seed. If we duplicate this, we'll have our handler for this one if we want to plant it, and then we duplicate it again like so. We don't necessarily want that. So we're going to have a single module script that we clone in each tool that we have. So in this module script, we'll call this activator, or we'll call this seed activator. And then we can head over to our inventory service. And this function handles all of the tools. In this case, we want seeds for our tools. So we can go ahead and go down here and clone our tool activator. So we can say local activator equals script.seedActivator clone and parent this to our tool clone. And we also want to require this activator, because if you recall, cloning modules doesn't do anything. We need to actually require the activator for any code in here to run. That's not in a function. So if we go to our seed activator, we can just comment this and call it seed activator, and then this is used for handling tools. And this is just a comment from me. Now we'll want to get two services. We want debris and we want our replicated storage. And of course we want to get remotes, and we want to get our services, our cached modules. So we just say require our cached modules, like so. Now the reason we can't do script.parent, which would refer to the server services, is because we've already parented this activator to our tool, which that means our parent or ancestry is changed, if that makes any sense. So we need to actually just do game.serverScriptService.our cached modules. And now we'll get our seed service. Cached modules at cached seed service, and we want our plot service as well. And now we'll start working on our activator. So obviously, always in module scripts, we need to return something. So we'll just return our activator like so. Or this can also be called module. It's whatever you think is best for you to understand. And then we'll reference our tool. Because if you remember, if we require a module script, anything that's not within a function like this will automatically be called. So this will all run when you require it. So we can reference our player, which is just our tool.parent.parent, because it's in our backpack now. And we can say, okay, whenever we activate the tool, we want to do something. And let's say like print tool activated, for example. So now if we just go ahead and play the game, let me go up here. So if we play the game, You notice we have our carrot seeds in here, and we go to our garden. See that whenever we click on the tool, you say tool activated, like so. So this is how we're going to handle planting our seeds. Alright, now that you notice that our actual tool activated thing prints out, we can work on actually planting the seeds. So first off, we want to check if the player is on a sort of planting cooldown, because we don't want the player to be constantly planting and spamming our planting or seed planting system. And next up, we want to actually get our plots. So we'll say plotService.getPlot player. As if you recall, that's how we scripted our plot service. We can say get plot, and it returns our plot model, which is a model, so we can reference it by saying model. And now in here, we can just add a debounce. So let's add a bool value. It can be whatever you want, but it just needs to be the name of this. Remember, debounces are just cooldowns in a way. So we can say debris add item debounce 0.5 seconds. I can say, okay, if we found our plot model, then we'll want to start actually trying to plant our seed. So that brings me to our second thing, or a sort of thing that I want you to understand and get to know, which are remote functions. Which they're different from remote events, because remote events don't return anything. Right, so you can't say like, okay, the on-server event and then return whatever thing we want. However, remote events can allow the client to actually get data from the server by returning it. Or vice versa, if you do on-client invoke, it'll return a value to the server. So what I mean is that let's go over to our starter player scripts, and we'll make a remote function called GetMouseCFrame, or GetMouseCF, which is short for CFrame. And then we can create a local script in our starter player scripts called GetMouseCFrame. So the reason we're not putting this in starter character scripts is because we don't want our event listener, to constantly be refreshed every time we respawn. So that's why we put it in here. And then now, if we can edit or start listening for our on-client invoke. So we can just call this GetMouseCFrame listener, and let's say players. And we'll also want our replicated storage, so we can reference our remote function. Local remotes. We can say we want to get the player first off. And we want to get the mouse, which you can do so by doing player get mouse. And now we can say remotes.getMouseCF to onClient event is equal to function, like so. And this is how you will always call or listen for remote functions, which is it's sort of different from remote events where you can do connect function, like so, which can sort of be confusing for beginners trying to figure out what the difference is. But always just remember to use equal function, like so. And then we can say return mouse.hit, which mouse.hit is just the CFrame of the mouse's position in 3D space, like so. And that is how we listen for remote functions. So if you are more confused about remote functions, you can just go to dev forum or your documentation and just look up remote function. And Roblox will give you a really in-depth explanation of what those are, as well as limitations and things like that. And yeah, that's pretty good. And now that we've finished scripting our client listener, we can go to our SeedActivator, go back, and then we can start scripting the planting seeds. So we can say local mouse CFrame is equal to remotes.getMouseCF invoke client player. And one thing I want to note is that whenever we invoke client, this whole script will yield until the client returns a value. So that's important to understand, because if we put this inside our character scripts, if the onClient event listener has not been created yet, then this will most likely yield this line of code forever, because the invoke client hasn't been initiated yet. That's important to note. And now we can say, okay, if we found the mouse CFrame, then we want to do something with it. So another function we want to make. So let's say, okay, if not plot service dot location is within plot, and we want to have two sort of arguments that we pass in, our player plot and our mouse CFrame, then return. So what this is saying is that, okay, if the location that we want to plant is not in our plot, then we want to just return end and stop the script. We don't want to plant if it's not within the plot. But you might be wondering, this function isn't a actual function in the plot service yet, which you're right. So we can create that function. We can collapse all of these because we don't really need to see those right now. And we can work on our function. So we can say function service.location is within plot. And you notice that we passed in our plot model and a CFrame. So we can say location, like so. Alright, so we can say if you have a plot and location, so if these two are passed, then we want to do something with it. Otherwise, we'll just return false, because it's not within the plot. And you'll notice that our plot that we always spawn in has a model in it called right soil, which is indicative of the location of which you want to plant at. So you see that that's all the locations we want. So we can go over here and we can say local right plot or right soil is equal to plot find first child right soil. If right soil, then we want to sort of raycast downwards. And what raycasting is, if you don't know, you can look it up on documentation, like so. And I'll say is raycasting is the act of sending an invisible ray from our origin point to a direction or a defined length. So if you watch the video, you see that, okay, this is sort of our origin point right here, and we want to raycast down until we hit something. Which you'll notice that the ray in this case is hitting the block, which is how they added a particle emitter right there, because they raycast and they got the results of the raycast and positioned the particle right at the bottom of the part, like so. So that's what we're gonna do, because let's say, for example, we have a really big plant. For example, our cacao plant right here. This is really big, so keeping that in mind, let's script our raycasting. So we'll say raycastParams.new and filter type equals raycastParams.filter type, or no, enum.include, and we say params.filter descendants equals our right soil. So we only want to include values that are in our model, our right soil model, like so. And now we'll say for underscore comma part, and right soil get children do. So we're looping through all of our parts right here. And then we're saying, let's make a comment here called casting downwards, like so. You can say local result equals workspace raycast, our location.position, and let's move it up a little bit. So we just want to move it up, so just in case if the position is in the ground, we'll move it up so we can give it sort of a room to breathe, in a way, is how I like to word it. And we want to raycast it downwards. -999 like so, 0, and add in our params. Now, the reason we're doing -999 is for the reason I discussed earlier, is because each plant is going to have a different size. So, for example, if our primary part location is right here, and we just raycast maybe 5 studs down, it's not going to touch anything in our soil. So we really want to emphasize raycasting straight down until it hits something, if that makes any sense. And for example, if we have like just a normal carrot plant right here, you notice, okay, if we were to cast maybe 5 studs down, -5, then it'll probably hit something. But for something bigger, it will most likely not hit the part. So that's where we're raycasting extremely far downwards. And now we can say, okay, if results and result.instance equals a part, so if we find if the raycast actually works and the instance that the raycast hits is a part within our soil, then we just want to return true. Otherwise, if none of this works, we're just returning false because it's not within the plot. And now going back to our locationIsWithinPlot, this function has now been added. And now, next thing we want to do is we want to get the seed offset from the ground. So what I mean is that if you remember earlier, I just discussed the problem with there being different sized plants. So if we go over here to our client model for cow or for carrot, and we move this up to our plot, you'll notice that the Roblox automatically snaps the location of it to the surface of the soil right here. And same thing with our cacao. If we move this right here and we move it up to our plot, it's automatically going to snap it to the surface. However, in scripting doesn't do that for you. So we need to actually account for the fact that, okay, the y-axis is definitely larger than the y-axis of just a carrot, which is small. So the way we're going to do that is we're going to get the seed offset from the ground. So you're going to say, okay, local plant model equals ReplicatedStorage.assets.plant, find first child, tool get attribute true name. Because remember, the tool name right now is probably something along the lines of our tool name, like carrot seed, and then the amount of carrot seeds we have, which is probably parentheses x20 or something like that. So we want to get the true name of this, and we want to split the string of it by space. Because our true name right now is probably something like this, carrot seed, like so. But if you look in our plants, you'll notice that our plants isn't named carrot seed, but instead they're named carrot. So we want to split our true name in half, which is going to return something like this. It's going to return carrot comma seed, because it splits it in half between the space. And then we can say, okay, it's an array, so we want to do 1, like so, which gets our carrot. Or if we have cacao seed, it's going to get cacao. And then etc, etc. So we can say, okay, if we found the plant model, then plant model equals plant model dot ServerModel. Because we don't really need to access the client model right now. Let me move both of these back over here. So we don't really need to access the client model, so we just use the server model because they're both the same size. And now in here we can say, okay, local plot CFrame, comma plot size equals player plot at right soil get bounding box. So what GetBoundingBox does is it gets the, if you move this over here, it gets the box right here, which Roblox displays for you. So it gets the location or CFrame of the box as well as the size of that box. And that way we can see how far we want to offset it from the ground when we plant it. So now, this is going to be a sort of a bit of a mathy part, which I'm going to try to explain the best I can. We're going to say plot CFrame dot position dot y plus plot size dot y divided by 2. So essentially what this code does is just gets the middle of our sort of plots in a way. It's a little bit difficult to explain it. However, what you want to know is that the rest of the code that I'm going to write is just going to find how far we want the plant to be offsetted from the surface to allow it for it to be planted correctly. So plant height offset is equal to plant model, that primary part, at size.y over 2, equals spawn position, mouse CFrame dot position dot x, plot top y, plus our height offset, and mouse CFrame dot position dot z. And then we just want to convert this to a CFrame, because that's where we're going to plant it. And finally, now that all of this is just offsetting from the ground, we can actually plant the seed. So we can say SeedService.plantSeed, and we want to get 3 parameters inserted in. So we'll say player, tool get attribute, true name, as well as our spawn position, like so. And this is going to be all that we need for our seed activator. So now we can exit out of this script and we can open our seed service right here. So if you recall, in our seed activator, we called on a function called PlantSeed, which now we need to make. So right here, we can say, okay, function service.plantSeed, and we want a player, and we want our tool or seed name, and we want the location that we want to plant at, which has already been incorporated to match the offset of different size plants. And now we can say, okay, local character equals player.character, and we can say if character, then, or we can say if player and seed name and location and character, then we want to proceed with the function. And three services that we're going to need is data service, we're going to need our inventory service, and we're going to need our plot service. And we also want to get the seed data based on the seed string. So we'll say SeedData module dot get data and our seed name. And once we get our player data, so we can say data service dot get data player. And if we have both this player data and seed data, then we can continue with the function. So the first prerequisite we want to check off is seeing if the tool is actually inside of the player. So let's add a comment here called checking for tool and character. We can say local current tool equals character, find for child, which is a tool. And if the current tool is there, and the current tool get attribute is seed equals true, which if you recall in our inventory service, actually we didn't actually make an attribute called is seed yet. So we're going to do that right here. So we can say, okay, along with our tree name attribute, we can also make an attribute called is seed, which just allows us to do quicker checking if we want to see if the seed is an actual seed or not. And now going back to our seed service, we can continue scripting this. So we can say, okay, if seed is true, and current tool get attribute true name is equal to the seed name, and then we want to do something with that. So essentially what these sort of 3 lines of code or 4 lines of codes are doing is checking if there's a seed that the player is actually holding out right now so they can plant, and if the seed name is equal to the seed that we're trying to plant and the argument that we passed. And now for another check, we want to see if the tool is actually in the inventory, which is the inventory save data of our player. So we can say checking for seed in inventory, local inventory equals player data.inventory, local found seed equals inventory seed name. And say, okay, if we found the seed in both the backpack or the character in the inventory, we can start planting. So we can say if player find first child, plant debounce, then return, and we're going to add a cooldown for planting. And we have to create a debris service up here. And we want to just destroy this after maybe 0.5 seconds. And now we're going to get our plot data. So plot player data dot plot data. So I want to preface that the way we're going to save the data is in our template profile data, and we're going to have another table called plot data, like so. So whenever we plant a new seed, in order for the database to be able to be saved, we're going to create a new value in our plot data, which holds sort of things like the location, the growth percentage, the last growth increment that we had, our date planted, and things like that. So we can go over here to our seed service, and we can say we can create a new function which checks if the actual seed that we're trying to plant is already too close to another plant. So let's make a comment and say if checking if too close to another plant. We can say local is too close is equal to service dot is close to plant. So we could actually make a new function. So function service dot is close, is close to plant, like so. And let's go ahead and script that real quick. So we can say reference point, which is going to be a part, PlotData, which is our plot save data in our data store, location we want to plant, which is going to be a CFrame, and our magnitude threshold, which is going to be how far away we actually want the plants to be from each other. So we can say, okay, if we have our plot data and our location of plant and our threshold and our reference point, then we can continue with that. Otherwise, we'll just return false. So right here, we can say local or for plant key string, comma data any and plot data do. So the way we're going to be saving our plots is going to be something like this. So we're going to have maybe like caret, and we're going to have a special key identifier like that. So we'll know which caret is which. And then we'll have a table like so. And we can have things like growth percentage, might be like 0, date planted, and we'll have location, which will say where location is saved relative to the plots. What I mean by that is, let's say we plant our seed right here, right? On this specific plot. If we were to save the location normally using the normal world CFrame, if you load into this plot right here, the seed will still stay planted here, which we don't want. So we'll save our location to where it's relative to each plot. So if we plant it right here and we leave the game and rejoin, the seed will be loaded right here, relative to each plot. So if we go back to our seed service, you see that we have plant key, which is going to be the key right here, and any data that we have, which is right here. So now that that's sort of out of the way, hopefully I can clear that up for y'all. We can work on the checking if it's too close to another plant. So we can say converting our saved location to world location for checking. So local location equals cframe.new table.unpack our data.location, like so. So the reason we use table.unpack is because data stores don't allow us to save CFrames. So we need to save our CFrames in sort of an array, which can look something like this. So we'll say like maybe 0, 5, like that, 0, 0, like so. So we're just going to unpack that table and put it into a CFrame. And now we actually want to convert this to make it relative to our plot that we're in. So we can see reference point.cframe to world space location, like so. And now we can get the distance from the location we want to plant and location that the current plant that we're checking is at. So we can say location.position minus location of plant.position .magnitude. And if distance is less than or equal to a magnitude threshold, then we return true because it is in fact close to another plant. And that is going to be our isCloseToPlant function. So hopefully I explained that in a way for y'all to understand. These comments hopefully can help y'all a little bit. Now if we go over here, we can actually reference our function now that we just made. So isCloseToPlant. And we want our plot service.getPlot player. And we want to make a new part called reference part, which is, we can just duplicate our TP part and call this reference points, like so. And let's go over here to our seed service and say .referencePoint. Now I want to note for y'all that reference point needs to be called reference point, so it needs to match up with whatever we call it in the script. And similarly, we'll need to duplicate the TP part for every single one of these. So reference point, go over here to 3, and we can call this reference point. Number 4, reference point, and number 6, reference point. And there we go. So now what this does is that whenever you load into a new plot, let's say your plot or your plant is saved right here. If you load into our 6th plot or 3rd plot right here, it'll load right here relative to location we saved at. So if we go back over here, we can say PlotData and our location, and 2.5 is our magnitude threshold. Now we can say, okay, if it is too close, then we return, and we can add a notification system later saying that, oh, you're too close to another plant. And now we want to reduce our seeds that we plant, which I'm going to add in later. However, now we're just going to say, okay, we want to change the location, this location right here, and make it relative to the plot's reference CFrame. Okay, so we can say local location to save, which is going to be different from this location, is equal to plot service.getPlot, our player, .referencePoint.CFrame to object space. And we can say location. So to object space converts this so it's relative to the plot location or the reference point. And now we can generate a key, so generating plant key, so we can differentiate between the different keys. And let's make a function up here called generateKey. Prefix, and which is a string. I'm going to say return prefix ... string.sub, and we'll just use Roblox's built-in sort of key generator. So HTTP generate GUID false, comma 1, comma 5. So essentially what this is going to look, if our prefix is caret, then it'll look something like this. So 1, 2, 3, 4, 5, like so. And if it's a cow, it can be cacao and something like that. And these keys will always be randomized, so that you'll have no similar key. So that should be good. And if we scroll down over here, we can generate our plant key. So we can say local key equals service.generateKey, our SeedData.seed prefix.value. So you notice that we just don't have that value yet, so we need to add it in. So go to our modules, caret seed, and we'll create a new string value called seed prefix, which is going to be called caret. This can be called like caret blah 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 or whatever we want. In this case, we'll just call it caret. It's because it's a caret seed. And yeah, that's it. And now we also want to add a couple more values to this. So a couple of values that we want to add. We want to add in a number value. And we want this number value to be called growth time, which in this case will make the seed grow in like maybe 5 seconds. Oops, let's move this out of server. And we also want to add in a value called harvest count. And this will see how many fruits can actually grow on the plant. So in this case, we'll make it 1. And I want to also add a bool value called multi-harvest. So in this case, caret seeds can only be harvested once, so we'll set multi-harvest to false. And we'll also add in a value called harvest interval. Let's move this back out here. So this is going to say a cooldown, or implement a cooldown for how long we want to be, or how long we want the cooldown to be between harvest. So we can make this like 5 seconds, like so. And that should be all of the things that we want in this case. So now we go back to our script. We can say, okay, local fruits array, and make an open array like so. Right here we can say for 1 comma, for I equals 1, so it's going to be a for loop. SeedData.harvestCount.value do. Fruits array I is equal to can harvest equals false. last harvest equals os.time, and mutations, we want to save no mutations for now. So let's say that, okay, we have like 4 different fruits. So we're going to save 4 different fruits in our fruit array, which each are going to have values like can't harvest, last harvest, mutations, and things like that. And then we want to actually now save our plot data. So we can say key is equal to open table, growth percentage is equal to 0, last growth increment is equal to the current time, our date planted is also equal to our current time, and location is equal to our location to save, get components, like so. And over here we can just reference this and make sure that this is a CFrame, like so. And you see that get components returns all of these values right here, which we want to put this in an array so we can unpack it up here. And now that should be good. And we're gonna add in our PlantEffect. So PlantEffect. And we're gonna put this in a test.spawn. So the first thing we want to do is that we want to raycast from the location to save. So we're gonna say raycasting down to the ground. We'll say local right plot equals plot service.getPlot player find first child right soil. And if right plot, then we want to say local params and just copy and paste the sort of raycast params we did in our plot service right here. Like so. And that should be good. Then now we can say, okay, if result, then we want to fire the client for our PlantEffect. So if you recall in our comment series, the way we did ClientEffects is that we created a folder called ClientEffects, like so, and we created module scripts in here, which is going to be exactly how we're going to do it in our Grow Garden game. So we can create a remote event called ClientEffects. Not a remote function, remote event called ClientEffects. And then we want to fire the client. So fire, events, fire all clients, PlantEffect, comma, location is equal to CFrame.new result.position. And that should be good for our ClientEffects. But now we actually want to listen for that. So we can go to our starter player character scripts and add in a script called ClientEffects. So we can say ClientEffects listener. So it's going to listen to whenever we fire the client. So, like last time, we will cache all of the modules. Local remotes. We'll wait for child remotes. Local ClientEffects. ClientEffects, and then we can say local cached module is equal to an open table. We say via's module script, then we want to cache it. And whenever we fire all clients, or list, or the on or fire client, we can connect that like so. So local found equals cached modules action. If found, then found data, like so. And now in our ClientEffects, we can create a module script called PlantEffect, which needs to correlate with this action right here in order for it to work. And then we can say return function, data, and we can create our PlantEffect. So we'll need debris service for destroying the PlantEffect. We'll need Schween service, and we'll need ReplicatedStorage. And we'll also want our assets folder and our PlantEffect. Now, one thing I want to note for y'all is that we're going to be tweening a model, which can't be tweened normally. So we're going to be utilizing something called getScale and creating a mock scale value so we can tween off of that. So I'll show you what I mean. First off, we need to get the location that we passed in. And we're going to clone the PlantEffect. And we want to anchor the primary part, which is this right here. And we want to set the primary part to the location.position and multiply it by Euler angles, which is going to allow this PlantEffect to be facing rotated to the bottom. So what I mean by that is, let's say that we don't rotate this at all. And we'll just parent it to the workspace.world.visuals. Let's create a folder called visuals. Workspace.world.visuals. And we're going to sort of tween this real quick. So scale value .name equals scale. Value.value equals 0.1. We want to parent this to the clone. And we'll say clone scale 2, which scale 2 can only be used on models. Value, and we'll say tween service, create, scale value, and create our tween info. And let's say let's wait 3 seconds before we tween it out. And we want to make this linear and tween it out. And we'll play it. And then in order for this to actually be able to be animated, we're going to check whenever the scale value is changed. And we're going to scale the model accordingly to the value. And at the end, we're just going to make sure that the clone is destroyed in 5 seconds, like so. So that's going to be our PlantEffect. So I'm going to show you all this without rotating the model first. So if we go to our seed service, you'll notice that, okay, we added that. And then let's go ahead and just print out our plot data. So you can see that the data is actually being added to our plot. So if we play the game, and we go to our garden, you'll notice that, okay, we can't plant anything outside. Oh, let's see what the problem is. Instead of saying PlantEffects, we're supposed to say plants, not PlantEffects, because we want to get this folder right here. So now, if we play the game and go to our garden, see, okay, we can't plant here, but we can plant right here. So let's see. SeedData, oh, right. So right here, you'll notice that we can't say number because value is already a number. So we're just going to remove this, and that should be good. And once again, you see we haven't added the reduction for seeds yet. So we'll add that momentarily. So now if we play the game, from our seed, you'll see that the rotation's sort of odd. And you see if we try to plant right here, again, you can't plant, but you can plant right here. And you see that our plant data is being added to our data store, like so. So in order to fix the rotation, we can utilize this right here and just say math.rad 90 to rotate it along the Z so it faces upward now. And now if we play the game, and let's try to plant in the location we tried before, and it doesn't work. And you'll see that, okay, nice, it works. And another thing we want to do now is sort of add in a highlight for the player to see whenever, or see where their plot is, or where the location they plant is at. So in order to do that, we can create a script in starter character scripts called seedToolVisual, like so. It's called seedToolVisual. Let's make a comment here for displaying the player's plot when holding a tool, like so. And in the plot, we want to create, and for the visual to work, we'll create a highlight in here. And then of course we'll just keep all of these the same, and we'll just set this to occluded, like so, because we don't want it to always be on top. And the way we're going to be able to set it to the plot is through Adorney, which is essentially the instance that the highlight is applied to, which it tells you right here. So if we go over here, we can start scripting it, so we can get our player, and we can also get tween service, like so. We also want our local player, and we want our character, which is just our script.parent. And we want the plots. .huge.map.plots. We want our humanoid. And we want the highlight to use, which in this case is a child of our script right here. And now let's just say, okay, we want to default the highlight, so defaulting highlight and creating tweens. Fill transparency equal to 1, and we want to create 2 tweens for when the player equips it and when the player unequips it. So we can say tween in, tween info.new 0.5, and we want it to be sort of quick. So we're going to use quint and out. And we want our tween out to be similar to this, so we'll just copy and paste this and just call it tween out and set the fill transparency to 1. And now that's done, we want to just wait until the player's data is actually loaded. And the first function we want to make for our detector is getPlayerPlot. So for underscore comma v, plots get children do, if v is a model, and v get attribute taken equals true, and v get attribute owner equals our player.userID, which is why we referenced our player. We'll just return the plot, otherwise we'll return no. And we'll just say repeat task.wait until getPlayerPlot. So we're going to wait until the player's plot is actually there. And we'll say highlights to use.Dorney is equal to our player plot. .right soil. And then now we're going to detect whenever the tool or a seed tool gets added to the player. Let's create a child added, child instance. If child is a tool, and child get attribute is seed equals true, which if you recall is why we added this attribute in here to make it easy for the client to know. And we'll say tween out pause, and we want the tween in to play, like so. And similarly, when the tool gets removed, we'll say, okay, we want the tween in to pause, and we want the tween out to play, like so. And that is our tweening script for the visual. So now if you play the game, and you equipped the tool, oh, it's not supposed to happen. So it's included, and oh yeah, we want the outline transparency to be 1. And that should be good. So if you play the game, you see that, okay, it's a blank slate right now, but if you equipped it, you notice that, nice, it highlights it for us, and we can plant the seeds, like so. And of course, if you try to plant in the same spot, it doesn't work. And now, we're almost close to the end of part 1. The last thing we want to do is actually want to make these seeds get reduced from the player. So we can create a function in InventoryService called RemoveItem. So right now in SeedService, we can say InventoryService.removeItem player, seed name, and how much we want to remove. In this case, just 1. And in our inventory service, we can actually start scripting that now. So we can say function service.removeItem player comma item name, which is a string, and the count that we want, which needs to align with whatever arguments we put in here. And we can say, okay, if the player is there and we have the item name and the count, then we'll get our data service. .data service. And we also want to get our player data. And if our player data is there, we want to get our inventory. And we want to get the item, or in this case is our seed. Okay, so if we say, okay, we found the item that we want to remove. and we'll say local remove item equals false, which the reason we're doing that is, let's say that the count of the item is reduced to 0. It wants to fully remove the item from the backpack and the saved inventory data as well. So we can say if found item.count, then increment down. So found item.count equals math.clamp found item.count -1, comma minimum, which is 0, and math.huge. And we can say, okay, if the count is less than or equal to 0, then remove item equals true. And otherwise, we can update the item count in the backpack. So service.inventory updated, our player, and the item name that we passed. And let's see what else. I found item.count, then otherwise, if there's no count, then we'll just remove the item, like so. And now in here, if remove item, then we're going to remove the item from the backpack. So inventory item name is equal to nil, like so. And we want to loop through the backpack to check for any tools that are left over. Because even if we destroy it from the saved inventory, it's not going to be destroyed from the backpack yet. So we say local backpack equals player.backpack. Local is seed equals server or seed storage. Seed storage, find first child item name. So if it's a seed, then we'll just loop through the backpack and check. So we'll say get_do if vget attribute is seed equals true, and vget attribute true name equals our item name, then we'll destroy it. And we'll break out of this loop right here. And down here, we can say add functionality for gears, etc. later. And next up, we're just going to loop through the character. Because, okay, let's say if the character has a tool equipped, it won't appear in the backpack. So we need to do a double loop to the character. So we'll say player.character, find first child, which is a tool. If tool, then if is seed, and tool get attribute is seed equals true, and tool get attribute true name equals our item name, then we'll just destroy the tool, like so. And that should be good for removing items from the backpack as well as our inventory when we plant seeds. So if we go back to our seed service, you see, okay, we remove the item, and let's go ahead and test if this works. So let's play the game, go over to our garden, and we'll try to plant a seed. You notice that, cool, it gets updated in our backpack. Let's go ahead and try to plant all of these seeds first, and see if it gets removed when we finish planting. We're on our last seed, and if we plant the last one, you'll notice that it gets removed from our backpack. And you also notice that in our plot data, you see that we have a ton of seeds being planted with different keys for each of these seeds, like so. And now, if we go over here to seeds and we buy some new seeds, you'll notice that we can't plant it in these spots because there's already some seeds here. But we can plant around the spots, like so. And yeah. So that's pretty much gonna wrap up part 1 of this episode 4, which is gonna go through planting seeds as well as your visuals. So, sort of a wrap up for this video. Let me exit out of all these scripts and go over what we did today, or for part 1. So the first thing we did is that we created a sort of a tool visual. So whenever you equipped a seed tool, which checks if it's a seed or not, then we sort of play an animation or a highlight on the plot to show where you can plant or not, which is what the seed tool visual does. And we also went over remote functions, which has a different way of calling them. And I want you to remember that it yields a script. So keep that in mind when using them. So don't use them sort of constantly if you don't need to. And the reason for GetMouseCF is that we want to see where the player wants to plant the seed on the server. And we also made a ClientEffect for our PlantEffect, which is done the same way we use our combat system. And we made a sort of a mock scale value to scale the model slowly. And in our seed data, we added new values in here called growth time, harvest interval, and things like that. And over here, in our inventory service, we created another function called RemoveItem, which removes any item that we want from the player. So for example, we plant our seeds, so we want to remove one seed from the player, as well as update it in the backpack, like so. And we also created a new attribute for the tool for easy checking if it's a seed or not. And we cloned the seed activator, which allows us to just handle activation from a single module script rather than going through all scripts in here in every single tool. So we added a cooldown, and we got the mouse CFrame from the client, and we create a new function in plot service to check if the location we want to plant is within our plot or not, using Raycasting. And we got the plant model, and we offsetted the value so it plants it based on the size of the plant model, the final plant model. And we planted the seed, which if we go over here to seed service, you see that we generated a key for every new plant that we planted, a unique identifier. And we checked if they're close to any other plant before planting. And we saved the location of our plants relative to the plot location, which is sort of brief overview of that from earlier is if we planted right here, it'll save that location. And instead of loading in, if you load into this plot, instead of the plant being spawned right here, it'll be spawned over here relative to the plot that we spawned at. And that function is done. And we also added our PlantSeed function, which does all of the checking and removes the item, and then it saves the item, like so, in our plot data. And we also added a PlantEffect, like so. And let's see if there's anything else that we went over. And that should be pretty much it. So a final showcase of the system that we have now is if we join the game and we buy some seeds. So that if we equipped it, then it'll highlight the plot, and we're able to plant the seeds with visuals. Well, no visuals yet, but we can see our data that we planted, like so. And yeah, that's pretty much it. Thanks for watching part 1, and see y'all in part 2, which is gonna go over visuals and actually growing the plants.